I will show you 4 powerful strategies for learning math that can transform how you approach problems and help you develop deep mathematical thinking. I will divide this video into 2 parts. First, how a good student should approach math. Second, 4 strategies that go beyond a good student's approach and can make you exceptional at it. Let us start with the first part, how a good student should approach math. To answer this, we need to understand 3 important things about how math really works. The first thing to understand is that math is built in hierarchical layers. Each new concept depends on earlier ones. If the earlier concepts are weak, the later ones become difficult to understand. Along with layered growth, earlier ideas return again and again in new forms at higher levels. For example, in algebra, we learn the slope of a straight line as change in y divided by change in x. Later, in trigonometry, we see slope in another form, that is tangent theta, which is the slope of a line that makes an angle theta with the horizontal. Then in more advanced topic like calculus, we study derivative, which represents the slope at a single point on a curve. So the same idea appears at different stages but in different forms. Because of this interconnected structure, many math problems can often be solved using more than one method. The second important thing to understand is that math is extremely precise. Consider these 2 expressions. Both expressions use the same numbers and operations, but the placement of brackets changes the final answer. This shows that math requires careful attention because small details can completely change the outcome. The third thing to understand is that math places heavy demand on working memory. Working memory is the part of your mind that temporarily holds information while you are thinking or solving a problem. It acts like a mental workspace where you keep track of what you are doing at that moment. When you solve a math problem, you rarely complete it in one step. You move step by step. To continue, you must remember what happened earlier. Sometimes you even need values calculated several steps before. The more steps involved, the more pressure is placed on working memory. When you study coherently while keeping these 3 things in mind, you become good at math. First, you make sure that earlier concepts are clear before moving to new topics. Second, you pay close attention to every symbol and every step instead of rushing through calculations. And third, you practice enough to make basic operations automatic so that the load on your working memory is reduced. If you study like this, you have solved half the problem. This will make you a good math student. But to become exceptional at mathematics, you need to go beyond this. And this brings us to the second part of the video, the 4 strategies that go beyond a good math student's approach and can make you exceptional at it. The first strategy is building schema instead of isolated skills. We saw that math is built in layers and how the same ideas return again and again in new forms at higher levels. But very rarely do we stop and connect what we learn in different sections of math with each other. When you connect related ideas across different sections, you build something called a schema in your brain. A schema is a connected group of ideas that your brain forms to understand and link related concepts. When your schema is strong, you start seeing multiple ways to solve the same problem, and that is what helps you choose the most efficient method. Let us understand this through one example. In geometry, you learn how to find the area of basic shapes, but in calculus, you learn integration to find areas under any curve beyond basic shapes. Now consider this problem. Given the function y equals absolute value of x, find the area under the curve from x equals -2 to x equals 2. Now what is the first thought that comes to your mind? We should apply integration. You split the function and integrate from -2 to 0, and from 0 to 2. It will take multiple steps, and you will get the correct answer. But if I ask you to now pause and look at the graph of this equation, it forms a simple V shape. And for given limits, from -2 to 2, it forms 2 identical right triangles. You can find the area of these triangles directly if you know the formula for the area of the right-angled triangle. This took just 2 steps, while the first method took many steps. What made this difference? The way you looked at the problem. You get the ideas of different viewpoints through schema you stored in your brain. That is why Building schemas makes your thinking more flexible and your problem solving more efficient. The second strategy is building intuition. Building intuition means developing the ability to look at a problem and get a rough idea of what will happen before doing detailed calculations. This skill develops when you compare problems that look similar but contain small differences. Let us understand this with the example of finding the distance between 2 points. This is the formula. Now consider these two problems. Find the distance between the points 2, 3 and 7, 7 and 2, 3 and 7, 3. Using the formula, you get the answers. Square root of 41 and 5. Up to this point, both problems look like simple applications of the same formula. But now stop and compare them carefully. In the first problem, both the x and y values changed, so the distance path becomes diagonal. In the second problem, the y values of both coordinates are same. This means the distance path is just a horizontal line. In this case, you did not even need the full formula. The solution was very direct. Once you start noticing such differences, your brain starts forming intuition. Before calculating the exact answer, you start predicting the type of solution the problem will require. This gives you more confidence and helps you solve problems faster. Strategy 3 is starting slow to solve fast. Good math students can solve problems, but strong math thinkers try to solve them with minimum unnecessary effort. It is good to know formulas, but more important than that is knowing which method best suits the problem and gives the cleanest solution. Therefore, whenever you see a problem, do not immediately start solving it using the first method that comes to mind, especially if it's a long calculation. First think, is there a smarter way before starting long calculations? If nothing comes to mind, then solve the problem using the method you know, but always make it a habit to pause and look for a simpler or smarter solution. The fourth strategy is post-mortem analysis. It means reviewing your thinking after solving a problem. Most students already do this when their answers are wrong. They look at the solution, understand the mistake, and practice the problem again. But post-mortem analysis is not only for wrong answers. Even if your answer is correct, you should still review your thinking. Why? Because getting the correct answer does not always mean your thinking was efficient or deeply understood. Like in the examples I showed earlier, sometimes you solve a problem mechanically without understanding the hidden pattern behind it. And sometimes you understand one method so strongly that you stop noticing alternative approaches. Therefore, review why you chose that method after solving a problem. This process of thinking about your own thinking is called metacognition, and this is really valuable for comprehensive and deep learning of mathematics. To broaden your thinking, look at how other people approach the same problem. Follow these strategies consistently while practicing math, and observe how your thinking changes over time. You can find all these strategies and a detailed guide to studying math on the website dfog.online. Subscribe to the newsletter on the website to get updates and new tools that support your learning system. If you have any doubts or questions, feel free to send them through the website. The link is also in the description.